figs. What's the rule?
Round your answer to the lowest number of the problem.
Yeah. So if you have 2, 3, 4 numbers in the problem and you're multiplying and dividing them, you round your answer so it has the lowest number of significant figures. Okay? So, for example, 2.3 times 125 times 0.0367. Just some random number. Let's put units on that. Let's go with centimeters. Centimeters. So go ahead, write that down, multiply it, use the calculator, and then tell me, or I'll call on somebody, or raise your hand if you want. Tell me the number you get on the calculator. Hey.
Here's your list. Minus other kids that go to other places. You know what I mean? So, like Melissa's kids will go with her.
Oh, okay.
So you're not looking for those
So I'm not
kids.
looking for those kids, right? Like I
Right.
was there last time, okay.
Yeah.
But we still have the same,
Yeah, you're just going to be over.
I'm still doing K through whatever.
Whatever you-
Yeah,
yeah.
whatever I was. Okay, nice.
All right. I'm going to go to emergency management after this.
You should.
After this life.
You'd be good at it. All right. So yeah, someone tell me if you've already typed it in there. What do you get? Go ahead, Max. All the numbers. 10.55 what? 125. Okay. And how many sig figs does 2.3 have? Anybody? 2. How many here? 3. How many here? 3. So what's our final answer need to be rounded to? 2 significant figures. So 10.55125, if we're going to round that number to just 2 significant figures, 11. 11 what? What's the unit on that? Centimeters cubed, right. Centimeters cubed. What is that a unit of measure for? Volume, right. Volume. Okay? Let's try another one. Let's say we have, I'm trying to give you more realistic numbers here. We have, let's say, 20.5 liters divided by, I don't know, what was the common measurement there? Let's say 0.55 liters. And it's only so hard I can make this here. It's pretty simple if you keep doing enough of them. So go ahead, round your final answer. Don't forget your units. And when you're done with this, take out your reference tables. I want to tell you a little bit more about why we're doing this. Okay, the answer is whatever Laura Griffin says. 37? 37 liters, very good. Is she correct? I don't know if that's the right number, yes? I trust her, okay? Why 37, Laura?
Because the lowest is 2.
Yeah, 2 here, 3 there, so it's gotta be 2, okay? It's gotta be 2. Questions with this? I don't think I need to hammer on this concept. You're gonna have a worksheet due tomorrow, practicing this anyway. So we don't need to take up time doing it now. You're gonna practice for homework and then we'll go over it. So multiplying and dividing, the rule is you round it to the lowest number of significant figures, okay? So if this number had 5 and this had 3, then that would have to have 3. So just make sure, first skill is be able to count, right? Count sig figs, and then the second skill is, okay, how do we round it according to the rule, all right? Okay, so that's kind of the easier one. Adding and subtracting is next, but first go to your reference tables, flip it on the back. Find this equation, MAVA equals MBVB. Okay, what's it called? Titration. We're going to be using that down the road, almost near the end of the year. What you're going to do is you're going to have three numbers and one variable. So in other words, the question would give you MA, it would give you VA, and it would give you VB. So you would have a number for this one, and this one, but you're looking for that one. And what you're going to do, and you're going to see down the road, is when you solve for that variable, the question is going to say round according to significant figure rules, or round to the proper number of significant figures. So when you have three numbers involved, you have multiplication, then division, you take your rules you're learning now, and you're going to apply it. That's just an example, okay? So throughout the year, I'm going to try and, sometimes I forget, but I will remember once in a while to say, oh, round your answer to the proper number of significant figures. There's another formula we're going to use. P1 V1 over T1 equals P2 V2 over T2. What's that called? Combined gas law, right. We're going to be getting into that a lot sooner, like next couple weeks. We're going to be using this. There's a lot of variables here. Multiply, divide. Again, we're going to be using significant figure rules that we're learning today to get our final answer. So on the regents, sometimes getting the answer is not good enough. That's like 1 point. The other point is the unit, and then the other point, sometimes it's 3 points, is using sig fig rules and getting the proper number of sig figs. So if your answer is supposed to have 3 sig figs, you need to do that. You're going to lose a point. So you could set it up right, you could get the right answer, but if you don't round it according to the rules, you'll get some of the points taken off. So I'm explaining a little bit more as to why we're doing it. Significant figures are relatively significant, but as far as you on a test or a quiz, this is kind of how we're going to be applying it. And in lab, how is it applied? I kind of explained that yesterday with the beaker, the graduated cylinder, scales. Some measurements or some equipment we use are more significant than others, more accurate, right? So I just like to explain sometimes why we're learning something, okay? So this is why we're doing it. All right, so adding and subtracting. Adding and subtracting with significant figures. All right, this is different. The rules are not the same. You do not round your answer so it has the lowest number of sig figs. Not the same rules, it's different. Let me give you an example, a couple examples, see if you can follow. Okay, 1.2 grams plus 0.25 grams plus 8.374 grams. Go ahead, write that down and add those all together. .2 plus 0.25 plus 8.374. Write it down, use the calculator. Write down all the numbers you see. Now I'll show you how to round it. Dylan, what'd you get? 9.824 grams. How come it's not grams cubed? Because you're adding, right? So when you add, it's just the same unit. Here's the answer. So this rounds to 9.8 grams. Let me give you another example. 230.65 milliliters minus 98.437 milliliters. Subtract those two numbers. I'll call on somebody to give me the entire answer, and then I'll show you how to round it. And then I'll call on someone to tell us what's the rule. Actually, I have a better idea. After we go over this, I'll tell you what the answer is. I'll have you guys pair up and discuss what the rule is. That's better. Then you can teach each other. Assuming someone knows what they're talking about. All right, what's all the numbers, Earl?
It's 132.
132.
213.
0.213?
Yeah.
Okay, milliliters. Okay. The answer is 132.21. Okay, it's called think, pair, share. That's what Miss McGovern calls it. It's probably like a legit name. I don't know all the fancy terms for things, I just do them. So it means you get together with your partner and then you're going to share. Think about it, get together with a partner and then share with the class. So these two rows and those two rows. Turn to your partner, discuss. What do you think the rule is? How do we know what to round? Share. And if you have odd numbers, just share so Bree can get involved there with Marcy and Emily and Mariana.
This has 5. This has 2. And this has 2.
Because it's the right answer.
Maybe it's the most. The most amount of significant numbers in the probability. The lowest, least amount of significant numbers. No, it can't be that. Huh? Oh, right. Yeah, but the thing is that's 9.8, and the biggest one there is 4. Maybe it's whatever the first number is.
Some of you aren't labeling units on your final answer like I am on the board. Label units. Units are real important. They're like shoes. Sure they are. Not really.
You definitely can.
You won't last very long.
You'll be at the hospital eventually.
You don't wear shoes.
It goes by the, see how this is.
Alright, how about your glasses? Units are like your glasses.
I don't wear them.
So we were the final answer.
Especially when I should wear them, I take
It's not my fault, I didn't clean them all the way out.
Yeah, that's what I thought. It's like the most, most common significant figure is the one, because this one's 5.
Alright, who has an idea for the class? Who's going to share? This is the share part.
Laura does.
There's 3.
Max was first. Okay. Laura, you said you had an idea?
Well, it's the second part that he said, but if you look at all 3 of them and see which one goes out to like the shortest decimal bit, like the 10th place. So you have the first one how it only goes out to the 10th place, and then you round it to the 10th place.
Okay.
And then on the second one, see how it goes, how the lowest amount of decimals goes out to the 100th place, and then you round to the 100th place in the answer. Yeah.
Laura is 100% correct. Very good, Laura. You round it. So Max, you were close with the lowest thing. It's not the it's almost the same thing, but it's a little different. So I don't want to confuse you. This has 2 sig figs, that has 2 sig figs, but we go with this one because the rule with adding and subtracting is you round to the lowest number of decimal places. So round to the lowest number of decimal places. So sometimes that is the smallest number of sig figs, but we're not counting the number of sig figs anymore. We're counting the decimal places. So this is the tenths, that's the hundredths, that's the thousandths, like she said. So the answer is the tenths. This one goes out to the hundredths, that's the thousandths, so, and then there's your hundredths. So you count the number of decimal places. That's 1 decimal place, that's 2. The answer has to have the lowest number of decimal places. That's how adding and subtracting works. Again, it's kind of like counting sig figs because this number will have, well, not always, but most of the time, the one with the smallest number of decimal places or lowest number will have the lowest number of sig figs, but again, that's not relevant here. So adding and subtracting, you're just focusing on the decimal places. All right, so let's try one more. And we'll move on. Talk about something else for the last little bit of class here. All right. So I don't know. There's only so many numbers I can make up in my head here. All right. Let's go with super tiny numbers. 0.0048 moles plus 0.0125 moles plus 1 mole. So once you learn the rule, I feel like it's not too difficult. Just got to remember. So if those are your numbers, we're adding and subtracting, so we're adding. Remember to round it to the lowest number of decimal places. I think you're going to get a weird number. Or it may not make sense to you. I did this on purpose. Oh, look what happened. This was our chromatography experiment. Yeah, who said yesterday?
Me.
Yeah, we had to let it work. Guess which one was the red ink? The red one. This was the black. How many different colors you see there? Yeah, 4 or 5 different colors there. Okay? So, which ink, the black or the red, was a mixture? This one, obviously. This was, well, okay, let me put it this way. They're both basically mixtures, right? Because the ink isn't a compound. There's no compound ink. And there's no element ink, right? Red ink. So, they're both mixtures, but really, even though they both look homogeneous, which one really is more homogeneous? The red one, right? This one technically is heterogeneous, but you can't see it. So ink is kind of almost like an anomaly. It's kind of hard to explain that. They both would appear homogeneous, but when you use chromatography, you can see this one is easier to separate, right? So based on our actual definitions of mixtures and substances, you could argue this looks like a substance. Uniform composition, you can't separate it physically, right? It has to be separated chemically. So you could argue that the red ink is a substance. I'm telling you it's not a compound. So it is a mixture, but it's a different kind of mixture than the black one. So the point is, this is how chromatography works. Why do some of the colors travel further up than the others? Explain what that means, stronger.
I don't know, I just remember that.
Why does this work? Why does chromatography work? Well, what happens to the water as it travels through the paper, right? The water is using cohesion, adhesion, attracted to itself, attracted to the paper. Why does the ink separate? What does the ink do in water? Dissolve. The only reason something ever dissolves in something else is because it's attracted to it. In lab, what dissolves the iodine? Well, the oil on your fingers, you saw that in the fingerprint. But when we clean out those flasks at the iodine station, so only some of you haven't done this, most of you have, or most of you have seen that, I think. What do we use to actually swirl it and clean it out? Alcohol. Alcohol dissolves iodine because alcohol and iodine are attracted to each other. Water and iodine not attracted to each other. So water and the ink are attracted to each other. Water, or the ink, is water soluble. So you said stronger. The higher the ink, the color is, what does that mean? The more it's dissolved, the more it's attracted, or the less it's attracted? This is where you answer, not me. In other words, the higher up, because the water's traveling. So if the ink stays with it longer, does that mean it's dissolved better or worse? What's the color on the bottom? Very bottom. Do you guys see that? Yellow. What's on the very top? Blue. So is the yellow or blue more attracted to water? Which one stays with the water longer? So would it make sense that we say blue is more attracted to the water?
Yeah.
So the pigment that lasts the longest and is the highest dissolves the longest, meaning it dissolves the best. So the one that gets stuck first here on the bottom doesn't dissolve as well in the water. What's the other argument you can make? I'll answer that. Maybe the red or the yellow pigment is more attracted to the paper than the blue one is. So it gets stuck on the paper. That's another argument you can make. But really it's about the solvent. As your solvent travels up, the longer the component stays in that solvent, the more it's attracted to it, the better it dissolves. So there's a lot to kind of understand with chromatography. I wanted to show you that's how you separate components in a mixture with chromatography. All right. So it was worth talking about that for a couple minutes. All right. Back to this question here. What's the answer? Shane. Just one. Wait a second. How can you take the number 1 and add 2 numbers to it and still get 1? Shane.
There's no decimal places, so that means it has the least.
Right. There's 0 decimal places here, so you can't have any here. But why? Why when you add, you're right, very good. That's the rule, good job. But why? Why does this exist? What's going on here? According to the rules, what does that say about these 2 numbers? They're not significant. Are these numbers much smaller than 1? Yes. So let me give you an example. You jump on a scale, you read your weight, okay, your mass. Someone gives you a feather. You're probably going to have the same weight on that scale. So that feather doesn't significantly change your mass or weight. So if you're making measurements with moles and you have 1 mole and then you add these tiny measurements to it, these aren't really affecting your outcome or whatever you are measuring. These are so small it's insignificant. Okay? It's like a drop in the bucket. You've heard that expression maybe? A lot of water, you add a drop, it doesn't really change it much. Just the same explanation. So I like to use something like that to kind of show you that it's confusing sometimes with these problems that you round according to the rules, and you're like, well, wait, you might as well not even have added those. Yeah, exactly. Because they're so small, this number is much more significant. Okay? So I'm going to stop with that. What you guys can actually do is pack up and just watch what I'm going to do. I'm going to give you your homework. This is due tomorrow. I will be after school. So you got a front and a back. I crossed off some on the back. Don't do that, obviously. And some of them are starred. I forget why. Maybe because they're, oh, I know why. Because they're tricky. They have 2 steps. They have 2 steps. Instead of just kind of one operation at a time, you got to do 2. So you'll see. Making it tricky. Yeah, you can put the calculators back.
Thanks. No.
I still like that. That's pretty cool. That's pretty cool. All right, so that's your homework. Put that away. Do the front and back. Front and back. Okay. Front and back. Put that away. Do not work on it now. That's a pet peeve of mine. All right. So we got a couple minutes. I'm just going to draw a few things on the board. See if you can follow me here. We're going to start talking about particle diagrams. Okay. All right. So, out of all those particles on the board, I want you to count how many of those particles are considered atoms, how many particles are considered molecules? That's the first question. Then I want you to answer another question. How many or which ones are elements, and how many or which ones are compounds? So basically you're picking out the atoms, you're picking out molecules, you're picking out elements, you're picking out compounds. This is the basis of what we're going to be learning tomorrow and Monday. So you need to know the pieces to actually put them together to draw what's called particle diagrams. So you need to be able to pick out atoms, elements, compounds, and molecules. So I'm going to get cut off. Can anyone tell me how many of these up here are considered atoms? Just 2. That's an atom, and that's an atom. Isn't everything made of atoms? Yes. We'll stop there. Tomorrow we'll pick that up. Don't forget the worksheet, and I will be after school. Have a wonderful day.